A diagram like this represents covalent bonding. Let me show you how it works. Covalent bonding is bonding that occurs between two non-metals. It involves atoms sharing pairs of electrons so that they can achieve a full outer shell and become stable. These bonds form because the positively charged nuclei are attracted to the shared pair of electrons by electrostatic forces. Covalent bonds can be represented using dot and cross diagrams, and these show the outer shells of the atom overlapping. Any electrons that are being shared are drawn in the overlapping section of the shells. So for example, if we had hydrogen, drawing a dot and cross diagram for a single hydrogen atom shows that there's only one electron in the outer shell. And as this is the very inner shell, it only holds 2 electrons. So you'd only need one more electron to get a full outer shell. So what you'll do is get another hydrogen atom and share the electrons. When this is done, you can see that the left atom has a full outer shell of 2, and so does the right one. This all makes the structure stable and forms a molecule of hydrogen, or H2. If you were to do the same with chlorine, you'd see that it's in group 7, so it has 7 outer electrons. This means they need 1 electron to get a full outer shell of 8. So 2 chlorine atoms each share 1 electron to make their structure stable and give a Cl2 molecule. Sometimes you need to share more than 1 electron. So oxygen, for example, has 6 electrons in its outer shell as it's in group 6. And that means it needs to share 2 electrons to become stable. This means there are 4 electrons in the overlapping sections. This would mean that oxygen has a double covalent bond because each pair of electrons represent 1 covalent bond, and oxygen has 2. Here are some more common examples of covalently bonded molecules. Now, the dot and cross diagram isn't the only way you can represent covalent bonding. These covalent structures can be represented in 3 different ways, and each have advantages and disadvantages. Dot and cross diagrams are good at showing where electrons of atoms have come from, but they're not good at showing 3D arrangements or the sizes of the atoms. Ball and stick models are good at showing 3D arrangement and sizes of atoms. However, you can't see the electron arrangements for the atoms. The quickest and easiest way to represent covalent structures are with displayed formulas. That's because they're easy to draw, but they don't show the electron arrangement or the sizes of the atoms. Alright, we've got a question here on covalent bonding. We've got a molecule of OF2. So you don't need to memorize this, they've just given this molecule in the exam and you need to apply your knowledge to try and figure this out. So we need to complete the dot and cross diagram, and you should only show the electrons in the outer shell. Right, so how do we work this out? First thing we need to do is work out how many electrons each of these elements have. So fluorine is in group 7, so that has 7 electrons on its outer shell. We've got 2 fluorine atoms here, and they've been represented by a cross in this diagram. So let me draw 7 crosses here for the one on the left and 7 for the one on the right. Now the oxygen is being represented by circles, and oxygen is in group 6, so there's 6 circles here. 1, 2, 3, 4, 6. Okay, 6. Now remember the aim of these. All 3 atoms need to get a full outer shell. They need to get 8 electrons on the outer shell. So what is the easiest way to do that? So this is covalent bonding because the dot and cross diagrams have the shells overlapping each other. So they need to share electrons so that they all have 8 electrons on the outer shell. So easiest thing to do here is to start with the atom that's only bonded to one other atom. So rather than starting with oxygen, it's probably better to start with fluorine because oxygen is bonded to 2 other atoms, fluorine is only bonded to 1. So fluorine has 7 electrons on its outer shell. How many does it need to get a full outer shell? It needs 1 more to make it 8, right? Where is it going to get that 8th electron from? Well, it's bonded to oxygen, so it's going to share one of these 6 electrons with itself. Okay, so I've taken one of those 6 electrons and I've put it in the overlapping section between the F and the O to show that they're sharing it. Now, we need to fill 7 electrons here. 1, 2, 3, 4, 5, 6 have been drawn, and 7th one I'm going to draw in the middle because that's sharing the electron. So now we've used the 7 electrons, And exactly the same thing happens on the other fluorine. So we can use those 7 electrons there. 1, 2, 3, 4, 5, 6, 7. And that's going to take one of the circles from above and share it there. So we've used 2 of our circles here out of our 6. What we're left with are 4 more circles. 2 of them have been drawn here already, so we can cross them out. And we're left with 2 more, so we add those 2 more there. And if you count them, you can see this one has 1, 2, 3, 4, 5, 6, 7, 8 electrons. So that's a 4 outer shell. This one also has 8. 1, 2, 3, 4, 5, 6, 7, 8. And this one has 8 as well. So all 3 atoms have 8. They're all stable. That's how the molecule looks like.